Okay, next started. So we've got y is 2 to the x and 64 to the x. Well, 64 we can write as 2 to the power of 6 because 2, 4, 8, 16, 32, 64. And that's the power x, which is 2 to the power 6x, which is y to the power 6. Next one, 2 to the power 3x at 4. We'll add means times, so 2 to the power 3x times 2 to the power 4. That's y cubed times 2 to the power 4 is 16. So it's just 16 y cubed. And the last one, 0.25 to the x is 1/4 to the x, which is 2 to the minus 2x, which is y to the minus 2. Yeah, it was a minus 2x because it was negative, because there's a fraction, and 2 squared is 4. Okay, second one. We have the equation y equals cube root x, and we've got the point x equals 4, and we want the normal. Well, straight away, get y, so sub in x's 8 into there, so cube root of 8 is 2, so there's the point 8, 2. And to get the gradient, we need to differentiate, so I'm going to rewrite y as x to the third, so I can differentiate now and get a third x minus 2/3. Sub in x is 8, so dy by dx is a third times 8 to the minus 2/3. I'm going to use my calculator, so a third times 8 power minus 2 over 3 gives us 1/12. Now, since it's a normal, my gradient is a negative reciprocal, that's minus 12. So then y minus y1 equals mx minus x1. And then just rewrite it however you want. So I'm going to take it to that side. So 12x plus y plus 94. Sorry, minus 98 equals 0. Yeah, that's better. Okay, next one. We've got an equation 5 to the 2x minus 12 times 5 to the x plus 20 equals 0. Okay, don't be tempted of timesing these together and getting 60 to the x. Remember, that doesn't work. Instead, be suspicious because we've got 3 terms and we've got one with double the power of the other one, so it looks like a quadratic. So y is 5 to the x, so y squared is 5 to the 2x. So my quadratic turns into y squared minus 12y plus 20 is 0. Solve that. So y is 10, or y is 2. So back in what y was, so 5 to the x is 10, or 5 to the x is 2. So x is log 5, 10, or x is log 5, 2. Okay, that's that one done. Fourth one. So we have a sequence un plus 1 is 2 over un, and u1 is 5, and we want sum from 1 to 100 of ur. So this thing here, that means u1 plus u2 plus u3. Look, I'm just changing r into these numbers, 1, 2, 3, all the way up to 100. So that means it's either going to be an arithmetic sequence, and I can use Sn, a geometric one, I can use Sn, or it's going to be some kind of pattern. So all we're going to do is have a play around. So u1 is 5, so u2, I'm going to sub 5 into there, so 2 over 5 just gives me 2.5 or 0.4 if you like decimals better. Then I'm going to sub 0.4 into there. So U3 is 2 over 0.4, which is 5. You should be able to spot a pattern now. So U4, if I set 5 into there, I'm going to get 0.4 back. So it's going to go 5, 0.4, 5, 0.4, etc. all the way to 100. So I'm going to get 50 lots of 5 and 50 lots of 0.4. So 250 and 20. So all together, now add them up, I should get 270. Okay, and the last one. So we got a car of mass 1,000 kilograms. Let's pull the trailer of mass 700 kilograms using a tow bar. The driving force of the car is 1,100 newtons. The resistance to the car is 200, and to the trailer is 100. There's going to be tension in the tow bar, and acceleration is going to go that way. So we need to find the acceleration and tension of the tow bar. So let's look at it as one whole thing. So 1,700, 1,100 pull it that way, 200, 100, so 300 pull it back. Tensions cancel out, and we've got air going that way. So we have 1,100 take away 300 equals 1,700 air. So air is 800 over 1,700. So air is 8 over 17, or whatever that is decimal. So 0.471 meters per second squared to 3 significant figures. Now I'm going to store that in my calculator, because I'm going to need that when I do the tension. So for the tension, I want to look at one of the objects. So the easiest one to look at is the trailer. So T, pull it forward, 100 pull it back, and I've just worked out that is the acceleration. So T minus 100 equals 700 times my input air. So T minus 100 is 392.411, blah, 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 blah. So add 100, and we should get, as a fraction, 7300 over 17. Or since mechanics, we like 3 significant figures, so 429 newtons to 3 significant figures. Then remember, you can always check with the car equation. So I'm going to store that as T. Where's T? There. So I'm going to check with the car. So pulling it forward, I've got that. Pulling it back, I've got 200 and T. Take away 200, take away T. So I get 470.58, blah, blah, blah. So that's my force, my mass times acceleration. I get the same answer, so therefore my A and my T are correct, and I've got all the marks.